Ring of charge with radius 0.5 meter has 0.002 pi meter gap, which is very small. This is one of the key points, that this is very small gap. If the ring carries a charge of 1 coulomb, the electric field at the center. So we have to find the electric field at the center, but if you consider that if this string were complete without any gap, then what would have been the electric field at this point? That we can easily understand. Let us consider a small segment of charge here, somewhere on the circumference. Then electric field due to this segment will be, we are just assuming positive charge, so away from positive charge means like that. And the segment diametrically opposite to it will create the similar field in opposite direction to cancel it. So in the same way, for other locations, the field will be cancelled from diametrically opposite segments. So net field for the complete ring at the center has to be 0. But here what is being done, that there is a small gap like a segment in the ring. So just diametrically opposite the similar part of the ring which is cut here, if we select diametrically opposite portion here, then we know that electric field due to this portion only is not being cancelled. Otherwise, for all other points, the diametrically opposite segments are possible. So here, the one approximation that I'm using, that this 1 coulomb charge is there on the complete ring. I'm neglecting this width. Although the 1 coulomb charge is distributed only on this portion of the ring. But since this gap is very small, we can consider it almost a complete ring. So what will be the charge per unit length? So first let us get the idea of charge per unit length. So total charge is 1 coulomb divided by length is 2 pi into r. R is 0.5 meters. So 1 coulomb charge is distributed over the length of 2 pi r. So delta Q, let us consider the charge equivalent to this particular cut portion, means the charge here, delta Q will be the charge per unit length multiplied with the length of the segment. So charge per unit length is 1 upon 2 pi into 0.5 multiplied with length of the segment, which is 0.002 pi meter. Okay. So this is the charge. So value of the charge is around 0.002 coulomb. So 0.002 coulomb is charge on this cut portion. That means the same charge will be there on the diametrically opposite segment, due to which electric field is there. Otherwise, for all other points, the electric field is cancelled. So we have to find the electric field due to this charge only at the center. And the direction of this field will be towards the gap, because here is the portion which is producing the electric field. So electric field has to be away from it since the charge is positive. So direction of net electric field will be towards the gap and away from the diametrically opposite segment. So what is this value of this electric field which is due to this particular charge segment? As we know that electric field is 1 divided by 4 pi epsilon naught into charge divided by square of the distance. Here the distance is the radius. Okay. So now on substituting all these values, what we get, delta E is equal to 1 upon 4 pi epsilon naught is 9 into 10 to the power 9 multiplied with the charge value. Charge value is 0.002 coulomb divided by R. R is R square. In case of electric field, it is R square. So R is 0.5. So 0.5 into 0.5, this is 0.5 square. So on calculating this, what we are going to get is 7.2 into 10 raised to the power 7 Newton per coulomb. So here you can see the option B will be the correct option to this question. So the whole idea was in this question that for the complete ring, the field at the center is 0. If we cut some portion on circumference of the ring, then the corresponding portion opposite, diametrically opposite to this segment will be the one which will be producing the field, and that field is not cancelled by any other segment. Otherwise, for rest of the ring, there is one diametrically opposite segment which is cancelling the field. Okay, so part B will be the correct answer to this question.